Hey everyone, today we're going to Leetcode 2698, find the punishment number of an integer. So for this problem, we're given an integer n, and we need to return the punishment number of n, and they tell us that punishment number is defined as the sum of all squares of all integers I, such that I is every number included and between I and n, and the decimal representation of I times I can be partitioned into contiguous substrings such that the sum of the integer values of these substrings equal I. So that sounds a little confusing, but basically what that means, and if we start looking at examples here, basically what they're telling us is we can partition the strings, or that I times I number, make it a string, and then partition it in a way that the number adds back up to I. So, for example, for 1, you can partition 1. Well, it's just a single character, or I times I, just a single digit. So that's 1. It's equal to I. So that counts as a punishment number. 9, we have 9 times 9 is squared, so 81, and we can partition 81 into 8 and 1. Which is equal to 9 if we add them together. So that's another punishment number. And then 10 is another example of one. 10 times 10 is 100. And if we partition it, just 10 plus 0, that's 10. And that gives us an answer. If n was equal to 10, it would be 1 plus 81, which is 9 squared, plus 100, which is 10 squared, and then 1, of course, is just 1 squared. And I think something important to keep in mind with this problem is the numbers don't just have to be partitioned once, it can be partitioned many times. So they kind of show us here in the second example with 36. So 36 times 36 is 1296, and that can be partitioned to 1, 29, and 6, which adds back up to 36. So just something to keep in mind. You don't want to just partition it once. You'll want to partition it as many times. Kind of every partition you can take, down to splitting up every number. Is fair game as far as this problem is concerned. So, I think a good approach for this problem would just be going from 1 to n, inclusive on both sides. And then we're going to want to find the sum of digits at each partition. And then if a partition is valid, return early. So that's kind of like a quick overview of this problem, but let's go step into Leetcode now and kind of see if we can get a better understanding of that and start writing out the solution. Okay guys, we're back in Leetcode now. So I just want to copy down the notes I took at the end in Excalibur. So what we're going to want to do is go from 1 to n inclusive. We want to find the sum of digits for each number I, and I will just be go I from 1 to n. So it'll just be every number between 1 and n. We're going to want to find the sum of digits at each partition. And then if it is a punishment number, which just means that the sum of the squared digits add up to the I itself, we'll want to add I to our answer. So let's see what that actually looks like in code now. First things first, let's just initialize our answer. Then we want to go from I to n plus 1 in this case because we want to be inclusive to n. And take squared equal to I times I. And if punishment number I. So if it's a punishment number, we're going to want to add square root answer. Now, how exactly do we find out if it's a punishment number? Let's start building that out. So I think the best way to do this is kind of like a DFS approach, where you check every partition itself. And you can end early if you can already tell it's not going to be a valid partition, but the idea is you don't know how many digits are going to be in that partition, how many partitions you're going to have to make, or what the partition will be itself. So I'm doing like a DFS approach where you just check every one is probably your best bet here. So what would we need for that? Well, I passed in I before, but we're probably also going to want the square number because that's what we're going to be using the digits from. And let's actually make this. Let's make this a string so we can index the digits by index itself. And then we're going to want I, not to get confused with this I firm down here, but this would be the index we are looking at in the squared number. And then we can just call this number remaining. And as we go through the partition, we'll just subtract our current count, our current addition we have going on based on the partitions from remaining. And we're going to want to try to achieve 0 from that, because we know if it's 0, that means all those partitions added up to I, which means we have a punishment number. So let's make that our base case, where if we check the length here. So if we exhaust the full squared size, have no more indexes to check, can't make any more partitions, and we're done with every number, we can just check if remain is equal to 0. If it is, it's a partition number. That'll return true, otherwise it'll return false. Now, how do we go and do the DFS approach of getting every number? Well, I think here we could do a for loop where we go from I to the end of squared, and the idea is we can start making partitions at every number. So for example, at 1296, we'll make a partition at 196, 1296, and all the way to say 1296, like that. And that also includes numbers or partitions like, I think that covers most of them actually, funnily enough, but that's kind of the idea here. So we're going to want a counter to kind of keep our sum going. And we don't know how many digits will be in that partition, so we'll just times that by 10 and add square j here, where 10 just kind of, we don't know if it's going to be, in this case where we don't know if it's going to be 2, if it's going to be 9, if we're in the second number now, we just don't know which where it'll be. And that'll also handle partitions where we partition every number, like 1296 here. We don't know if we're going to be at, if it's all going to be 0 digits, we'll have a 7-digit partition in there. We just don't know. So that's how we handle that case. And then we could just kind of walk down the recursive tree. So we can do if punishment number and make the recursive call squared. The next index would be j plus 1. And then this is where we'll subtract our kind of running count going. And if that's there, that's true, we return true. Otherwise, if we get to the end, we don't get anything, we return false. And I guess a little optimization we can make is check if remaining is less than 0. Since we're only subtracting, once we get to this case, it's considered, we'll know it's not a punishment number. We can kind of cut off that partition earlier. So that should be all we need. We can go ahead and run the test cases. Made a typo here. Or no, I just didn't fully type this out. So we want to pass in just 0 for I. And you see that passes these test cases. Let's submit, see how that goes. Yeah, and there we go. So if this problem helped you, please comment below, let me know. If there's any more comments you'd like to do, or any more problems, also let me know. But thanks for watching, and I'll see you guys next time.